Okey, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh dan salam sejahtera. Sayang kumbang mencari makan, terbang seiring di tepi kali. Selamat datang kami ucapkan, moga diiringi restu ilahi. Bersyukur kita kehadrat ilahi, justru dengan inayah dan kurnianya dapat kita berkumpul bersama-sama dalam sesi Ulangkaji Berfokus SP025 Program Kecemerlangan Akademik Kolej Matrikulasi Negeri Sembilan melalui YouTube Live. Marilah kita mengikhlaskan kehadiran kita dalam majlis ilmu pada petang ini demi kecemerlangan pendidikan dan kebaikan pelajar kita. Tahniah kepada semua pelajar yang sanggup berkorban masa untuk berada di sesi Ulangkaji ini. Sesungguhnya menuntut ilmu itu tiada had dan batas sepadanya. Semoga usaha kita semua diberkati Allah. InsyaAllah. Pelajar yang disayangi, Madam mohon semua untuk share sesi live ini kepada kawan-kawan, tak kisahlah sama ada di KMS atau bukan di KMS, untuk sama-sama kita mendapat kebaikan. Bagi memberkati majlis pada hari ini, marilah kita sama-sama mulakan majlis kita dengan bacaan Ummul Furqan Al-Fatihah. Amin amin ya rabbal alamin. Madam harap semua pelajar sudah bersedia. Sebelum bermula, Madam nak ingatkan bahawa kehadiran dan borang penilaian akan diberi di akhir majlis nanti. Tanpa melengahkan masa lagi, majlis sukacita menjemput penceramah sesi Ulangkaji Berfokus SP025 sesi 2021-2022 iaitu Madam Nun binti Noh, pensyarah Fizik Kolej Matrikulasi Negeri Sembilan dengan berpengalaman mengajar lebih 23 tahun. Beliau mempunyai pengalaman dan pernah menjadi Ketua Pemeriksa PSPM. Dipersilakan.
Okey, Assalamualaikum warahmatullahi taala wabarakatuh dan selamat sejahtera semua. So, apa khabar semua? Boleh dengar? Boleh tekan 1 kalau boleh dengar? Pelajar yang hadir, tekan press 1 dekat live chat kalau you can hear my voice. Okey? So, saya ucapkan selamat datang dan terlebih dahulu terima kasih kepada moderator kita, Madam Syahidah. Okey, dan bersama kita di konti, kita ada Madam Emma sebagai observer dan Mr. Edward sebagai host controller. Okay, thank you so much everyone. Thank you Irina, Awais, Idham, Madam Fitrino Shakila. Thank you so much for the response. Okay, very good. You are ready for our discussion today. So, without wasting our time, so for today's, as all of you know, petang ni kita akan adakan sesi Ulangkaji Berfokus, tapi sebelum tu saya akan kongsikan beberapa tips dan teknik menjawab soalan PSPM sebagai tambahan kepada preparation yang you all dah buat selama ni. Okay, so di sini saya akan kongsikan tips dan teknik menjawab soalan fizik. Okay, so the main point is, of course, I'm sure that everybody ready for the PSPM, right? Because of PSPM is just around the corner. Okay, so thank you so much Shazdian, Kaisha, thank you so much. Okay, so okay, make sure that the first thing that you need to do, you need to set target to get physics A, and for all subject you're supposed to get 4 flat. Okay, that's the most important. If you have no dream to get A, it is very difficult for you. So set your target. It is okay, you can set today to get A for physics. Of course, I'm sure that, and all of us here, all the physics lecturers always pray for your success. Success meaning that you get A in physics, okay? And then this is a few tips. There are 5 tips or steps to answer physics question that I can promise you, if you follow this 5 steps, you will get full maximum marks. Maximum marks meaning that it is referred to what you answer, what's you write down on the booklet answer. So as long as you write down the solution, you will get marks. Okay. So what are these 5? What are the 5 steps? 5 tips or step? Okay. The first one, I hope that you alert. I always remind to a few classes. So for those new with me, okay. So I hope that you alert because of during my discussion of the past years after this, I will follow this step. Okay. So the first step is you need to list when you read the question. When you get the question, when you get the past year's question, you need to read the question, of course. So what you doing when you read the question? Of course, sambil you baca soalan, make sure that you list all the information given from the question. So how you want to list the question? How you want to list the information? So you need to use the correct symbol that represent the value that given to you in the question. And of course, you need to change to the SI unit. And when you get the information, you can find the hidden info. I will show you after this how to get the hidden info. Okay, that's the first important step when you read the question. And then the second step is you can sketch the related diagram or figure, if any, meaning that if the question that relate to the diagram or figure or the graph, you can sketch the diagram. Or if the diagram is given to you, you can copy back, and make sure that when you copy the diagram, make sure that you copy. Don't ever you just conteng dalam kertas soalan, sebab sometimes tu jawapan you yang you conteng di atas booklet soalan, you akan bawa balik, bawa keluar. So tak ada markah. Sometimes there is a hidden marks there. So make sure that you copy back and with the correct label your diagram, especially the graph. Okay, make sure that you know the tips I will highlight in our discussion today. And then uh, the third step is you need to identify and choose related formula or equation. So this is all of you are really very lucky, because of the equation is given to you, the formula is given to you. So you just need to choose the correct equation. But how? Which equation that you want to choose? You're supposed to know with you. Make sure that for those yang masih tak ada lagi list of selected constant, yang tak kisahlah online ke digital ke ataupun on paper, make sure that you have it, because of this is your talian hayat during the PSPM. So when you want to choose the correct equation or formula, make sure that you refer to the step 1. Which step? Step 1, which is when you list the information referring to the correct symbol, so you can match with the equation given there. Sometimes you not remember which equation that you want to choose, but referring to the symbol, referring to the information that you list, you can identify the correct equation. Okay, and then when you get the equation, of course, the fourth step is you're supposed to substitute the value in the equation correctly. So my suggestion is you use the standard unit. Normally, I will suggest to you SI unit, or let's say if you substitute in centimeter, for example, so all the value that you substitute in the centimeter, for example, it is can, tak semestinya SI unit, but the best is SI unit lah. And then final answer with your correct unit. So this is the most important, because of here the last step need guarantee 1 marks for this part. So your correct answer sometimes confused berapa decimal places ke significant you want to write down. So I give you tips. Normally final answer we refer to 2 decimal places normally. Okay, 2 decimal places. For example, 1.23 is 2 decimal places, or if your answer is involved 0, so you can state 3 decimal places. 3 significant figure, because of 0, this 0 is not include, right? So you can write down 3 significant figure. So this is the 5 step that will help you to get maximum marks referring to what you answer in your answering booklet. Okay, so do take note that. Okay, I hope that these tips, please remember, follow the because of my solution after this, my discussion is following this step. So please remember, it doesn't matter how many resources you have. You have a lot of Telegram group, PSPM notes, PSPM, past year question, solution answer, all the things. But if you do not know how to use them, it will never be enough for you as your reference, for you to get A. So make sure that this 5 step, I hope that can help you to get maximum marks for your PSPM. Okay, now we go to our main purpose is to discuss the solution for the past year question session 2019 and 2020. For all of you, for all your information, this past year, actually this is during the PKP, so this session PSPM tidak dijalankan. So that's the special sikit lah, maknanya the solution depends on the solution. That's why I want to discuss this question. Okay, now but at the same time I want to remind you, as I said, the third step, you need to choose the correct equation. So the list of selected constant and the list of selected formula yang you ada itu adalah talian hayat you semasa PSPM. So I hope that before the physics subject, before the physics exam nanti, make sure that you do the analysis. Buat analisa sedikit di atas list of selected formula ni, which soalan nombor berapa sampai nombor berapa, topik mana, so that you familiar with the selected formula, this selected formula. Okay, so take a look at question number 1A. All right, if you have any question, you can write down in the chat box. So Madam Syaida, Madam Emma, Sir Edward will help you to provide the answer. If you have any question, okay, you can write down on the chat box. Okay, so are you ready? Okay, can you press 2 if you're ready? Ready meaning that with you you have the solution. If not, it is okay, so make sure that you take note for all the important things. So those who are ready, can you press number 2 in the chat box? Okay. Okay, thank you, Shaz. Thank you, Irina. Thank you for the response. Okay, I hope the rest are ready too. So for question number 1A, the electric field at a point of 10 centimeter away from the charge P, as shown in the figure, is 2.7 times 10 power of 6. Okay, at the same time, as I said, when you read the question, make sure that you list the information. So when you want to list the information, make sure that, okay, thank you, Nabio, Atika, Aisha, thank you. Thank you for the response. Okay, so for example, it's stated that the electric field at point 10 centimeter away from charge P, meaning that the R. Okay, this is what I mean. You need to list the information given following the correct symbol. So it is represented by R 0.10 meter because of this given centimeter. And then the electric field given is 2.7 times 10 power 6 Newton per Coulomb. Okay, and then you need to determine the charge of P. So QP. Okay, this is also another tips. Make sure that you identify what you need to calculate because of sometimes dalam satu soalan ada dua perkara yang you kena kira. If you not highlight, you termiss. You hanya kira perkara pertama, perkara kedua dah terlupa nak kira. Okay, so that's also the important tips. So that you will try to answer even you don't know the solution, but you still try to answer the question. Okay, so how? Because we have the E, R, and Q. Can you guess which equation that we can use? We can choose. You can choose referring to the list of selected formula. I will refer to the list of selected formula too. Yeah. So I hope that you alert. For example, in this case, because of kita ada E, R, and we want to calculate the Q, so we can use the equation for the electric field, which is given from the equation 3. Referring to the list of selected formula, you refer to the equation number 3. So E is equal to KQP over R square. Satu lagi perkara saya nak ingatkan. Bersyukurlah persamaan telah diberi. Make sure that you salin persamaan betul-betul. Jangan terlupa tersalah salin. For example, sometimes you miss square ni, R square you terlupa. So make sure that you write down correctly. And then the second step is, first step you list the information. So the diagram is given to you here. You just need to refer to the diagram. The third step is you identify the equation. Fourth step is you substitute correctly. So in this case, because of Newton per Coulomb is the SI unit. So of course R, as I said, supposed to be SI unit. And you final answer with the correct unit. So do you try to answer this question? If you have tried to answer this question, maybe you also can write down the answer in the chat box. Okay, so the answer for the charge of P is 3 microcoulomb. So in this case, for the prefix, you can give your answer in the prefix or you can write down times 10 power of negative 6. Okay, but the unit, don't forget, referring to the what you're supposed to calculate, the unit is coulomb in this case. Okay, so this is question number 1A. So for question number 1A, just now is 1A1, right? Okay, if you refer to the PSPM question, there is a 1A2. Okay, which is with reference to the figure 1, a charge Q is placed 10 centimeter away from charge P. When the charge Q is moved horizontally to the right to a position of 5 centimeter from its initial position, there is a 0.54 joule change in its electric potential energy of the system. So if you read the question carefully, okay, I just write down here, Ri is initially, Q is position 10 centimeter from charge P, and then they move to the this position, which is 5 centimeter, meaning that it is a final position, 0.15. Total distance from charge P is 0.15 meter. Okay, and then change. Okay, read the question carefully. Change in its electric potential energy, delta U. it is represent the delta U. So it is equal to 0.54 joule. And then we want to calculate the charge of Q. Okay, so how? So in this case, the tips is the concept. This is the concept. Change its electric potential energy. So we will refer to this is the initial to final position. So change in electric potential energy equation. If you refer to the list of sector formula, it is equation number 6, right? So you write down first the equation for delta Q, referring to the question directly. You write down the equation, and then take a look here. Because we want to calculate the Q naught, we have delta U, okay, and then we supposed to know delta V. Do the delta V given here the potential different? No, right? So you need to calculate first. So you need to calculate the change in electric potential first, which is delta V. So which equation that you want to use? So in this case, you can use the equation for V, which is KQ over R, and to calculate the change in potential energy. So of course, V final minus V initial. So when you do the calculation, you will get the value for the change in potential and electric potential is negative 90 kilovolt. Okay, so don't worry with the sign, just substitute in the equation. So we substitute the delta U and also delta Q, and then you can calculate the charge of Q, which is in this case the charge Q will be negative charge, which is negative 6 microcoulomb. Okay, so this solution you're supposed to show in your solution also. Okay, please don't write down. Please don't sketch the solution to calculate the delta V on the question paper. So all the calculations supposed to be in the solution booklet. Okay, please remember that. Okay, now we go to the question number 1A3. Okay, panjang ya soalan nombor 1. Okay, you need to sketch referring to the same diagram. Sketch the electric force vector on charge P and Q. Read the question carefully. You need to sketch. Electric force is a vector. So you need to sketch the F on the charge P and Q. So you're supposed to have forces. Two forces, which is because of charge P. If you label the charge, in this case, you need to sketch the diagram, right? So easier for you to identify. Of course, your answer you're supposed to sketch the charge P and Q. So you label P as positive 3 and Q negative 6, referring to the value that we have calculated. Okay, and then of course, because of P and Q is opposite sign, okay, so the force exerted is attractive force. So you just need to sketch the arrow towards each other, and please label the arrow that represent the force. If you need to sketch two forces, so make sure that you label each arrow, because of the marks is with the arrow with labeled. Okay, bukannya direction saja. And don't worry, what happen if your calculation for P in 1 and in 2 you calculate Q is wrong? So let's say you get this is positive and this is positive, so your direction is in the opposite direction, right? Still consider correct because we refer to your previous answer. So don't scared to answer all the question, even you're not confident, even you know your first step is wrong, but you just follow. Just try to answer following your answers. Okay, don't worry. And then for question number 4, if charge Q is again moved horizontally to the right to a new position and the electric force on it is negative 4.05 Newton, how far apart is charge Q from charge P? So in this case, now Q is in this position, new position. So we want to find the R, the distance from charge P. And we have the charge exerted on the Q, which is negative 4.05 Newton. Why negative? Because of to the left. Okay. So to calculate the electric force here, because we want to calculate how far, and we have the tips is we have the electric force. The value for the electric force is given. So you can refer to the equation number 1, which is the Coulomb's force, KQQ over R square, and then you substitute the value for F, Q, K. K is also another thing. K is we call it hidden information. Remember I told you hidden information, you also can write down the hidden information. Sometimes the hidden information is referred to the list of selected constant value. Okay, so this is the hidden information. Okay, don't forget, because of don't confuse, because of K, there are two value for K in the list of selected constant. You all present up. The first K is Boltzmann constant, which is we use it in the first semester. So the second is the constant for the Coulomb's law constant. Okay, so do take note about that. Alert, don't just write down the constant. Be careful with the constant. When you substitute and you calculate, you will get the R, the distance from charge Q, new position of Q to the P is 0.2 meter. Okay. So if you have any question, you can write down in the chat box. And if you understand, if you clear, you can write down clear in the chat box. Okay. All right. And thank you for all the response. Okay. So the next question is 1B. Okay. For question 1B, two oppositely charged parallel plates are held 2 millimeter apart. Okay. So take a look at the list of information given. I write down that the D, which is given 2 millimeter, change to the SI unit. 4 times 10 power negative 5 joule of work. So W is 4 times 10 power negative 5 joule. Is needed to move a 2 microcoulomb point charge. So it is Q from one plate to the other. Calculate the electric field between the plate. So we want to calculate the E. So what equation that you want to use? Of course, if you refer to the information that you have list, we can use equation E is equal to V over D because of we have D and we want to calculate the E. But we also we have no value for V. So V is electric potential. But here we have the W, the word. Okay, so we can use the electric potential equation, which is equation number 4, and then you can calculate first the electric potential, and when you get the electric potential, then you substitute in the equation of electric field. So when you substitute, you will get the answer for the electric field is 10 kilonewton per coulomb, and as I said, kilo is a prefix. Okay, you can write down kilo, or you can write down times 10 power of 3 newton per coulomb, doesn't matter. All right, so is it clear everyone? So I hope that everybody clear. Maybe you can write down in the chat box. Okay, we go to the next question, which is question number 2A. So question number 2 is referred to the topic 2. Okay, which is about the capacitor. So the graph in figure 2A shows how the charge Q on a capacitor P change with time. Okay, when it is charged through a 20 ohm resistor. Okay, thank you so much, Rose. All right, and then determine the capacitance of the capacitor P. Okay, there are few information from the question, which is R is given as 20 ohm. Okay, another information is from the graph. So please do take note. If given to you the graph, make sure that you get the information from the graph. Write down the information from the graph. Don't just look at the graph. Okay, so referring to the graph, we know that it is a charging process. So charging process, okay, we have the terms of what we call it, time constant, right? Time constant. So there are two value for the t at the x-axis here. So don't confuse. You need to have the understanding about the charging process, where we refer to, because of tau is given here. Why I choose q is equal to 0.63 q naught when tau is equal to 80, okay, 80 microsecond, because of this is time constant. What is the definition for time constant? Or if you refer to the equation, time constant is given as in equation 14. So what is the definition of time constant? So time constant is the time taken for the charge to increase to 63% from its initial value during the charging process. So kenapa dia bagi 0.37 Q naught ni? So ini hanyalah gangguan kepada soalan sahaja. So make sure that you have understanding about the time constant. So in this case, if you know that the hidden info, which is the tau time constant here, which is equal to 80 microsecond, it is very easy for you to calculate the capacitance. Because of referring equation 14 just now, tau is equal to RC, you substitute the tau 80 micro. Okay, please remember prefix. Okay, so just not remember, because of my calculator ada symbol prefix, I can press the micro. So those calculator yang tiada, you supposed to substitute 80 times 10 power of negative 6. Okay, please remember. Okay, please remember. And then R is given as 20. So when you calculate, you will get the capacitance is equal to 4 microfarad. And as I said, 4 micro, or you can give the answers 4 times 10 power of negative 6. Okay, clear, right? Okay, so now we go to the question number 2B. So for question number 2b, capacitance P is then arranged as shown in the figure 2b. So make sure that you take note, this is capacitor P added here. Okay, referring to the figure 2b. So you need to determine the effective capacitance for this combination, for this circuit. So can you identify which one is parallel and which one in series? So first, if you look at here, C1, C2, and C3 are in series. How we identify the series combination? It is referred to the current that flow. Let's say if these two channel connected to the power supply or to the voltage supply, so when the current flow at the junction will divide into two, meaning that the current that flow in this through the C1 same with the C2 and also C3. That's why C1, C2, and C3 is in series combination. So, and you are quite lucky because of this semester, they changed the equation, not this semester lah, the equation for the arrangement of the capacitor in series or in parallel, the equation is given to you, which is equation 11 for series arrangement, equation 12 for the parallel arrangement. But make sure that when you calculate, make sure you calculate the things that you calculate is capacitance for combination capacitor C1, C2, and C3. Okay, which is 0.97 microfarad. But this is not our answer, right? Because of we need to combine with the P. Now, C1, C2, and C3 and P are in parallel. Am I right? Both of them are in parallel. So we will use the parallel equation to calculate the effective capacitance. Finally, you will get that the C123 is 0.97 micro and C4 is 4 micro. So you will get the answer for the effective capacitance for this arrangement is 4.97 microfarad. Okay? So I hope if you have any question, you can ask. Yeah? No worries. Okay, now we go to the question number 3A. So question number 3 is from topic 3. Okay, electric current and direct current circuit. Okay, referring to the question given for the circuit in the figure 3.1. First, we need to determine I1, I2, and I3. Okay, I1, I2, and I3. So if you look at this, or if you start with the question number 3, you're supposed to understand that it is a electric current and direct current circuit. So this type of circuit given to you, you need to apply the to calculate the current I1, I2, and I3, it is supposed to refer to the Kirchhoff rules, right? Okay, so this is the step I share with you to apply the Kirchhoff rules. So if you are given the circuit like this, first you need to identify the direction of current. So normally the direction of current we identify at the junction. So in this case, because of the question on the label I1, I2, I3 without the direction, so we need to identify the direction of current. Okay, let's say we refer to the EMF. So I2 is entering the junction and I1 and I3 is leaving the junction. We follow the EMF. Doesn't matter actually where's the direction. If you label in the opposite direction, you will get the negative value. That's it. Okay. So the first step is we identify the direction of current if not given to you yet. If given to you, so you just leave it for the first step. Go to the second step. So for the second step, we need to you need to identify the direction of EMF, and the tips if is for the EMF, you need to label the arrow from negative to the positive terminal. So because of that, if you look at the purple arrow from negative to positive terminal for each EMF, okay, that's the direction of EMF. And then the third step is you will identify the direction of loops. So the tips is for to identify the direction of loop, we refer to the EMF in the loop which is greater value. This is the greater value. So if you refer to the first, if you choose this is as a first loop, so the direction of EMF, the bigger EMF is 7, so the direction of loop is referred to the direction of EMF 7 volt. Same thing with the second loop, okay? And then we can apply first Kirchhoff rule and second Kirchhoff rule to calculate the I1, I2, and I3. Okay, now we have done the first 3 steps for the Kirchhoff rule. Now we go to the solution. We will apply the first Kirchhoff rule, which is first Kirchhoff rule state that the sum of current entering the junction is equal to the sum of current leaving the junction. So because of that, if you look at this junction, so we can write down the equation which is I2 entering the junction equal to I1 plus I3 because I1 and I3 leaving the junction, and you rearrange the equation because of kita akan selesaikan menggunakan equation dalam calculator. So we get the first equation. And then second step is we apply the second Kirchhoff rule untuk loops, okay, for the loops. So referring to the loops 1, which is the second Kirchhoff rule, is sum of EMF in the loops is equal to the sum of the product of current times with the product of current and resistance. Okay, because of that we get the equation of E1 plus E2. So if the direction of EMF and the current same direction with the loop, the sign is positive. So in this case all of them are in the same direction with the loop, so we get that the second equation. Okay, I just substitute following the given info in the circuit, and then referring to the second loop, we apply the same Kirchhoff rule for the second loop, and then you will get the third equation. So in this equation, if you refer for the value that there is no value, for example in the third equation, there is no I1, so I1 is equal to 0. Sorry, 0 I1. Okay, because of no I1 here. Okay, so uh you just need to substitute in your calculator, right? I hope that you're familiar with this. So you will get directly the answer for the I1, I2 and I3, which is I1 is 0.56 ampere, I2 is 0.99 ampere, and I3 is equal to 0.42 ampere. 0.42 ampere. Okay, so I hope that if you get the different answer, okay, you can state here your answer. We can check, maybe my calculation is wrong. Okay, so you just write down there, or if our solution is different, you can write down on the chat box. Okay, now, the question number 2 and 3. Question number 2, after we identify I1, I2, and I3, we need to calculate the number of electron passing through the 9 ohm resistor in 2 seconds. So, as I said, because of the additional information, so we want to calculate the number of electron. Number of electron is represented by N. And then given the passing through the 9 ohm resistor. So 9 ohm resistor is R2, and then we get the time into second. And okay, if you see this arrow in my solution, so meaning that it is hidden information, which is we know that because of it is involved the 9 ohm resistor, so the current that involved is I2, which is 0.99 ampere that we have calculated in first part. Okay, you can use that value. Okay, so how? Okay, if you do not know number of electron, which one is the equation that relate with the number of electron? So this part, it is very important when you list the information. You will see that you have the current, the hidden information, which is the current, and we have the equation for the current. If you refer to the list as related formula, it is equation number 20. Equation number 20, I is equal to dq per dt, and equation number 21 is q, quantization of charge, q is equal to ne. So we just replace q as ne. So in this case, you can calculate the n. That's why it is very important for you to identify what you want to calculate so that you can relate with the equation given in the list of selected formula. Okay, so in this case, it is quite easy, right? Because of I2 is 0.99 and we want to calculate, and E is the elementary charge. So please refer to the list of selected constant, which is the value is 1.6 times 10 power of negative 19, and the T is given as 2 seconds. So just substitute, you will get that the N, the number of electron, which is equal to 1.24 times 10 power of 19 electrons. Okay, don't forget to write down the unit. If you leave it your answer like that, there is no marks for the final answer. Okay, please take note about that. And then for question number 3, we need to calculate the power dissipated by 5 ohm resistor. Okay, so for question number 3, we need to calculate the power. So I give the power question mark because we want to calculate. And then 5 ohm resistor is represent R3. So we can identify the hidden info, which is I3. I3 that passing through the R3 is 0.42 ampere that have been calculated in the first part. Okay, so referring to the information given, can you guess which equation that you want to use, or you can choose P? You have P, you want to calculate the P. You have the information about the R and I, so you can refer to equation 28. Okay, if you refer to equation power, equation 28, which is I square R. So we can use that equation. So power is equal to I square R. So I is 0.42 square, R is 5. So you will get the power which is equal to 0.882 watt. Okay. So it is quite easy, right, for you to identify, and you can see that it is very easy. I just write down the equation that relate with the information given, because of you need to identify the hidden information from the question. The hidden information is also from the first part that you have calculated. This also can consider as the hidden information. Okay, and the last question is question number 4. With the same circuit, you need to calculate the change in resistance of the 2 ohm resistor. Okay, when there is a 30-degree rise in its temperature. So take note with the statement. Okay, if you look at the information given, the first thing is identify what you want to calculate. You want to calculate the change in resistance, so delta R. Normally, change in resistance or different in resistance, meaning that R final minus R initial. Normally, okay. So give question mark there because we want to calculate. And then 2 ohm resistor is initial resistance, okay. And then the rise in temperature, meaning that delta T, not the final temperature. Please take note about this. Maknanya peningkatan dalam suhu, maknanya perubahan suhu. Perubahan suhu yang berlaku adalah sebanyak 30 degree Celsius. Okay, so it is represented by delta T. And the coefficient of resistivity is given as 6.8 times 10 power negative 3 per coulomb, per degree Celsius, sorry. So, okay, now can you identify the equation that you can choose to answer this, referring to the information given? So very easy, right? You want to calculate the change in resistance, and we have the temperature. We also have the coefficient of resistivity, which is alpha. So you can choose equation number 24. So referring to the equation 24, okay, write down first the equation 24 as given in the list of set formula, and then you rearrange. You rearrange until you can get the change in resistance, which is delta R. If you cannot find the delta R, you just find the R minus R naught first. So from there, you R minus R naught is delta R. So just substitute the value for coefficient of resistivity, and then the initial resistance, and also the rise in temperature. Okay, when you calculate, you will get the change in resistance is 0.408 ohms. Okay, clear, right? So I hope that you are following me. Okay, so the next question is question number 3B. Because of the part topic 3, it is quite long, right? So it is a lot of questions that relate to the topic 3. Okay, so for question number 3B, figure shows a potential divider circuit. Calculate the output voltage. Okay, first we want to calculate the output voltage. The output voltage is here. Soalan very simple. Okay, so when you list the information, you just need to refer to the diagram. So referring to the diagram, the info that we have, sometimes they just give 6,000 ohm, 3,000 ohm. So it is very easy for you if you can list label R1, R2, because of it is more than 1 R. If 1 R, it is okay. So if more than 1 R, you can label with your own symbol. So in this case, I label with R1, 6,000 ohm, R2 is 3,000 ohm, and then supply voltage is 12 volt. We want to calculate the output voltage. Because of it is stated, it is a potential divider. So if you refer to the list of the formula, potential divider equation is equation number 30. Okay, so you can write down the equation for the potential divider, but you need to match with the question, because the question said that you want to calculate the output voltage. So your output voltage, the ratio of your output voltage to the voltage supply equal to the resistance, okay, for the output voltage divided by total resistance or effective resistance, referring to the supply voltage. Okay, in this case, okay, you just need to substitute the value given to you in the from the question, and you will get that the output voltage is equal to 4 volt. And the tips is this output voltage is supposed to be less than the supply voltage. Okay, because of this is series combination of the resistor. Okay, series combination of the resistor. Don't forget, we just connect to the voltmeter just to calculate the potential difference. Okay, all right. So now we go to the question number 2. Okay, for the question number 2, if a voltmeter of resistance 3000 ohm is connected across the output. Okay, at the output, okay, I sketch the new diagram. I not disturb this diagram. So this is the diagram that you're supposed to write down in your booklet, solution booklet. So the output voltage, now the voltmeter resistance is 3000 ohm. So I just represent by R3. And then we need to determine the reading of the voltmeter. So in this case, you can see that there are 3 resistance. And you're supposed to identify the arrangement of the resistance. For example, R2 and R3 are parallel arrangement. So you can calculate the effective resistance for the R2 and R3 first. So if you calculate the effective resistance, which is referring to the equation 27, Don't confuse with the capacitor. Dia terbalik kan. For the parallel and series arrangement of the capacitor with the parallel arrangement of the resistor. So parallel arrangement, equation 27, you will get that R23 is 1500 ohms. And to calculate the potential divider or to calculate the output voltage now, reading of the voltmeter now, okay, we use the potential divider equation. So in this case, total resistance, effective resistance is considered R23, a series with the R1. So 1500 plus 600. And for the output voltage is across the parallel arrangement of these two resistors, which is 1500 ohms. And you calculate, you will get that the output voltage is 2.4 volt. Okay, the answer is 2.4 volt. Okay, so is it clear? Am I too fast? If you think that I am too fast, you can write down fast in the chat box. If okay, just state okay. Huruf O dengan K. Alright, in the chat box. So I know your situation. You understand or not, or you can follow me or not. Okay, please, write down in the chat box. Okay, we go to the question number 4A. So, for question number 4A, okay, 4A ni very good question. You need to read the question carefully during the PSPM later on. So, figure 4.1 shows a rectangular wire loops, 0.3 meter times 0.2 meter. So, at the same time, take a look at the given information here. Okay, 0.3 and 0.2 meter for the rectangular wire wire loop. Dia bagi just to confuse us. Okay, moving horizontally to the right at 12 meter per second in the uniform magnetic field. So you're supposed to imagine the magnetic field is produced, the uniform magnetic field is produced from the south, this magnet bar, south and north pole. Okay, between that. And the strength of the uniform magnetic field is 0.8 Tesla. Okay, B is represents 0.8 Tesla. The induced current in the wire is 3 ampere. Okay, di sini dia dah highlight kan. Actually, we refer to what types of conductor. Okay, so but we just write down I because of this is the current is equal to 3 ampere. So first we want to calculate the resistance of the wire loop. Resistance of the wire loop. Read the question carefully. Sometimes because you just see the rectangular loops, you will always think about the loop, but the passing area through the magnetic field is only wire QP. Okay, passing the magnetic field, okay, is the wire QP. So to calculate the resistance of the wire, first we need to calculate the induced current in induced EMF in the wire QP. Induced EMF in the wire QP, in the wire, not in the loop. So kalau you cari loop, memang you pengsan, you will not get the answer. So you calculate the induced EMF in the wire first, referring to the equation of BLV sine theta, because of all the information given. How you identify the L? If you look at the given information, there is no L, but it is a consider hidden information, which is L is here. L is 0.2 meter. Because of QP, the length of the QP is 0.2 meter. Okay, so when you get the induced EMF, then you can calculate the resistance referring to the equation. Actually, this is the equation of Ohm's law. Yeah? V is equal to IR. We just apply with the EMF. Okay, so our EMF that we have calculated for the wire is 1.92. Just substitute. The induced current given is 3. So the resistance is equal to 0.64 ohms. Okay. All right. So that's the first part. The second part is the direction of the induced current. So we have identified the magnitude of the resistance of the wire. And now we want to identify the direction of the induced current. So to identify, because you need to explain how you determine the direction of the induced current. So to explain, okay, of course, this is chapter 4, which is about the electromagnetic induction. So first we need to refer to the Lenz's law, which part of Lenz's law that we can apply. So Lenz's law state that when the wire passing through the moving inside the magnetic field, the magnetic force will exerted on the wire, and the direction of magnetic force supposed to oppose the production that producing it. Okay, the production that produce the induced current. So of course oppose the V. So in the top view, you can sketch the top view. Okay, how you want to imagine? Okay, the first one, you can sketch QP, the wire QP first, and then magnetic field. Why the magnetic field symbol is dot, not cross? because of magnetic field is the direction of magnetic field is from north to south, meaning that passing through the Q, the direction of B is upward. So we can see the dot only. That's why represented by dot for the B, and V is to this direction. And referring to the Lenz's law, we know that the magnetic force exerted oppose the V, so we have the FB here. Now, referring to the Fleming left-hand rule, remember the Fleming left-hand rule? FBI, we want to identify the direction of the induced current. So F is to the left, B is upward. So you will identify that the direction of the current is, induced current is from Q to P. Okay, you can sketch or you can mention from Q to P. It is quite easy if you mention from Q to P. So this is the reason how you can explain the way to determine the direction of the induced current. Okay. So for question number 4B, okay, for question number 4B, okay, at the same time, please take a look at the information given. Yeah, a 6 centimeter long solenoid. So LS, I just represent by LS, which is 0.06 meter, with 400 turns. So N is 400 turns, and cross section area 7 times 10^-4 meter square. Experience a changing current as shown in the graph. So this is the graph of I versus T. We get from the graph, okay, what you will get. Actually, this is the hidden information from the graph. If you calculate the gradient of the graph, it is represented by di per dt, because of I is y component, t is x component. So di per dt is equal to 2 ampere per second. Okay, 2 ampere per second. So this is the hidden information from the graph. First, you need to calculate the induced EMF. So, because of, if you refer to the information given, because of we have di per dt, how you want to relate with the induced current, we refer to the equation of, there is a lot. If you refer to the list associated formula, a lot of equation for the induced EMF. Am I right? Starting from equation 43 until equation 48. So which one you want to use? This is how important is the list of information given. When you list, you can identify there is the hidden info from the graph, which is the I per dt. So you can choose to calculate the induced EMF by using equation 48. Okay, equation 49. Even the giving to you the solenoid. So tak semestinya you need to use the equation for the EMF of the solenoid. Okay, so referring to the induced EMF relate to the di per dt, you need to have the inductance. Okay, L is the inductance for the solenoid. So referring to this equation, di per dt ada, we want to calculate the induced EMF, tapi LS is, there's no inductance for the solenoid. So what you need to do, you can calculate first referring to the equation of the inductance for the solenoid given, which is equation 51. 51, yeah. So referring to that equation, you just need to substitute. Do take note that we have the permittivity constant here, mu naught, 4 pi times 10^-7. And then N is 400 square. A, just substitute the value and you will get that the answer for the self-inductance is 2.35 times 10^-3 Henry. Substitute in the equation, the induced EMF equation, you will get that the induced EMF is supposed to be negative 4.69 times 10^-3 volt. Okay. So this is how we apply two equation in one solution. So actually this is category C4. You need to identify the you need to find another info first, then you can substitute in the main equation. Okay. All right, now we go to the question number 4B. For question number 4B, we want to calculate the magnetic flux through each turn and the store energy. Okay, in this case, the things that I want to highlight to you is there are two things that we want to calculate, which is magnetic flux and also the energy store in the through the solenoid, in the solenoid. So first, to calculate the magnetic flux, okay, because we have calculate the inductance of the solenoid, we can use equation number 49. So equation 49 is L is equal to N phi over I, and phi is the magnetic flux. So you need to relate, as I said lah, the first, before you calculate the induced EMF, you calculate the inductance for the solenoid, right? So we will use the value in the second solution. Okay, so you can substitute and you can calculate the magnetic flux, which is equal to 1.76 times 10^-5 Weber. Okay. And okay, because of there are two things that you want to calculate. So the second one is energy store. You are very lucky because of for the energy store, in the inductor, only one equation, which is equation 52. U is equal to half Li square. Just substitute the value for L and I. Okay. So in this case, because of L, the first question is you need to calculate the induced EMF. So be careful with your L. Make sure that you calculate carefully the L, because of in the second solution, both magnetic flux and energy store, you need to substitute the L. If you initially calculate wrong for L, you will get no marks, because of L is not the value that you're supposed to find the answer. Okay, so please be careful with that. So in this case, for the energy store in the solenoid, it is equal to 10.58 millijoule. So don't confuse, yeah. Milli is 10 for times 10 power of negative 3. Okay, joule. Okay, that's the solution for question number 4b. For question number 5a, so for question number 5a, it is about the alternating current. Okay, alternating current. So referring to the question, given the phasor diagram for the RL circuit, so I just sketched the circuit, which is consists of RL connected to the VRMS or AC source. Okay, RMS voltage across the inductor. Okay, do take note, this is very special. This is the RMS voltage across the inductor. So the list that you need to write down is VRMSL. Okay, equal to 62.8 volt. Frequency is 50 hertz. 0.8 Henry for inductor. And unknown resistor. So we don't know the magnitude of the resistance. We need to calculate. Okay, first question is we need to calculate the resistance of the resistor. So how? In this case, actually, we can get the hidden information first, which is XL, because we have L here. R kita tak ada kan? Okay, tunggu dulu. So kita cari L dulu. XL, which is the inductive inductive reactance. Okay, so when you calculate, you will get the equation is 2 pi f given to all of you, right? Which is equation 59. So walaupun dia tak suruh kira, but you can find the hidden information referring to the list of selected formula given to you. Okay, you calculate the first XL, and then referring to this, if you refer to the, because of this is alternating current, you're supposed to know which equation start for the list of selected formula given. So referring to the equation 61, because it is referred to the RL circuit, so XC is equal to 0 lah, referring to the equation 61. So if XC is equal to 0, so the equation is tangent theta is equal to XL over R only. And then because of kita ada phase, the different 35 degree here, so we can substitute and we can calculate the R, substitute the XL that we have calculated, so you will get the resistance is equal to 358 ohms. Okay, so this is the answer for the question number A1. How about question number A2 for the peak voltage? Okay, so for the peak voltage, if you look at here, the equation for the peak voltage is referring to the equation of 57, right? Equation 57, which is VRMS is equal to V naught over Z2. Okay, referring to that equation, so meaning that we need to have the VRMS first. VRMS. So how to calculate the VRMS? So we know the equation for VRMS is IRMS Z. Why RMS Z? Because of our circuit is considered RL circuit. So we need to know the Z, which is R square plus XL square. R we have calculated in first part, which is 358 ohm. XL is also calculated in the first part. And IRMS, we have no value for IRMS. Do differentiate between the VRMS here with the VRMS given in the question. Because of this, VRMS is referring to the VRMS across the inductor. Okay, so we need to calculate IRMS first for us to get the VRMS. So how? So we refer, because we have the inductance, capacity, inductive reactance, and also we want to calculate the IRMS. We have the VRMSL. So when you substitute, you can calculate the IRMS. Substitute IRMS inside this equation with the R and XL that have calculated in first part. So you get the VRMS. When you get the VRMS, you see the step of, if you want to calculate the peak voltage, substitute the value for VRMS, and then you will get the peak voltage, which is 154.5 volt. So this is the step. This is category C4. C4 question, meaning that you need to do few calculation before you get the correct answer. All right. And then for the average power. So average power quite easy, right? Because we have a lot of value here. So you can choose to use the equation for average power, which is equation 63, because we have the value for IRMS, VRMS, and cost phi. So you just need to substitute the value that you have calculated, but make sure that you choose correctly, which is IRMS and VRMS, not the VRMS across the inductor. Yeah. Okay, so when you substitute, you will get that the average power is equal to 22.37 watt. Okay, if you look at here, all the equation is inside the list of the formula given to you. So talian hayat, this talian hayat that given to you supposed to be help you 100%. Boleh tolong you 100%, then you can get full marks. Okay. And then for figure 5b, for question 5b, figure 5 shows a phasor diagram. So this is a phasor diagram. Oh, this is the same question, but B, for the B, okay, for question B, if the resistor is removed from the circuit, okay, resistor is removed, draw the variation of current I and voltage V against time on the same labeled graph. Current and voltage, then you need to label. Okay, so what happen when we remove the resistor? So this is become the pure inductor circuit. Okay, pure inductor. So saya suka untuk share dengan you, ini perkongsian daripada ketua panitia kami sivil, ya, perkataan sivil, nanti saya jelaskan. So first, okay, for us, because of the state, you need to draw the variation of graph, current and voltage versus T graph. So you double axis siap-siap. Paksi Y adalah current and V with the correct unit, and also X axis T with the correct unit. Okay, that's the first step, because this is the first marks when you label your graph correctly. Okay, second step is what you supposed to label. So untuk you label, you refer to the Y component and X component. So at the Y component, because of kita ada I and V, so you need to know the value for the peak voltage and also peak current. So peak voltage we have calculated in second part just now, right? Which is 154.5 volt. So we have the value for the peak voltage. How about the peak current? So how you want to calculate peak current? We not calculate rate yet, because of previously we calculate the IRMS. So from the IRMS that you have calculated, you can calculate the peak current. So peak current 0.35 ampere. Now at the Y axis is settled. We have the I node and V node. How about at the T, at the X axis, at the X component? What you supposed to label? You're supposed to label the period, right? So how to get the period? So we refer to the frequency given. So you can calculate the period. So this is all the information that you're supposed to label on your graph. Okay, so how do you know for the in a pure inductor or pure capacitor, current lead the voltage or voltage lead the current? Okay, I like to share with you the civil, perkataan civil ni ya. So in this case, referring to this question, sebenarnya nak ingat senang je. C ni refer to the capacitor, L ni refer to the inductor. Okay, so civil, capacitor, IV ni I lead voltage. Okay, untuk capacitor I mesti lead voltage. So of course lead by pi over 2 lah kan. And then for the inductor V lead I. Sometimes tu kita just confuse je sebenarnya sama ada current lead or voltage yang lead. So referring to the civil, so capacitor mesti I lead voltage, tapi untuk inductor voltage lead I, ikut susunan IVI tu. Itu cara yang saya rasa sangat bermanfaat lah. Saya boleh ingat sampai bila-bila. Okay, siapa yang lead siapa. So referring to this, okay, so you can sketch. Now you know that the current for the inductor, pure inductor circuit, voltage lead current. So current, kita sketch dulu graph current, and we can label the period. Okay, and also the I node for the peak current. And for the voltage, because of voltage, for the inductor, voltage lead the current. VI kan voltage lead the current. So, of course, for the voltage, the lead, dia ke depan sikit. So, this is V node. Okay, so this is the graph that you're supposed to sketch with the correct labeling for the V node, I node, and also the period. Okay, baru you boleh dapat markah penuh untuk graph. Okay, you need to label. Why you need to label the value? Because you have calculate the value. Okay. Okay, thank you so much, Cik Sally. Okay, that's very good prayer for all of you. Okay, now we go to the question number 6A. So for question number 6A, 6A is about the geometrical optic. Okay, geometrical optic. So this is a lot of tips in this topic. An object is placed 15 centimeter in front of a mirror. Okay, so referring to the information, U is 15 centimeter. The image formed by the mirror is upright and magnified 2 times. So because of, remember the sign convention for the mirror, for the upright image magnification is positive. Okay, so first you need to identify either the mirror is convex or concave. So explain your answer. So in this case, because of this is upright image, the types of mirror is concave mirror, and the object is magnified. Okay, this is two reason why it is a concave mirror, referring to the sign convention. Okay, and sorry for question number 2, what is another characteristic of the image? Because you need to explain your answer, so you can say that instead of upright, of course lah, virtual, right? But you need to explain your answer. How you want to explain? So you can calculate, referring to the magnification equation. So magnification equation, if you look at the list of selected formula, it is equation 68. 68, yeah? M is equal to negative V over U. We substitute the value for U and also the magnification, we get the V. Okay, because of kita nak another characteristic of image, so kita cari V. So when you do the calculation, you get the V is negative sign, meaning that it is a virtual image and also form back of the mirror. So maybe dia just nak satu je another characteristic, but you need to mention, you can mention both lah, the location of the image too. Okay, and the third one is determine the radius of curvature of the mirror. So of course, to determine the radius of curvature of the mirror, you need to calculate the focal length first, because of we know the relationship, which is the radius of curvature is equal to 2f. So you have the value for u and v, and to take note that the v that you have calculated is negative. So you just substitute negative here, you get the f is 30 centimeter. Substitute, actually this is also proven that it is a concave mirror because f is positive. If f is negative, it is a convex mirror. Okay, and then you will get that the radius of curvature is 60 centimeter. All right. Okay, so this is quite easy for question number 6A. Okay, take a look at question number 6B. For question number 6B, figure shows a lens with a radius of curvature of 15 and 50 centimeter, made of glass with refractive index of 1.55. Determine the focal length and types of lens. There are two things that you need to identify. Okay, so referring to this question, radius of curvature is 15 and 50 centimeter. How you want to identify which one R1 is 50 or R1 is 15? How? If you look at list of information, how I identify R1 is 50 centimeter, R2 is 15 centimeter, and both is positive. How? So I give you few tips. Okay, first, consider the object position. Okay, let's say the object position is at this position, meaning that in front of the lens. Okay, and then there's a, please take note about this note. Okay, the first thing is surface near to the object supposed to be R1. So any position of object doesn't matter, because of the surface which is near to the object will be R1. So in this case, we know that this the first surface, okay, the green surface ni, saya consider the circle lah, the green surface is the R1. So how I identify R1 is 50, not 15. So take a look at the second surface. Okay, take a look at the second surface. Second surface, kalau sebab bulatan, you can see that the radius is less. The radius is smaller compared to the green radius. Am I right? So R1, it represent the 50 centimeter and R2 is 15 centimeter. That's the way how we identify which one is R1 and R2. Tak semestinya kalau dia bagi yang pertama tu adalah R1, yang kedua tu R2, tak semestinya. Ataupun you also can assume kalau dia bagi R1, the first one is 15 centimeter, meaning that the object is located in front of 15 centimeter, but you still need to identify which circle giving you the larger radius. Okay, so if you refer to this tip, it is very easy. Doesn't matter where is the position of the object, you can identify. So in this case, now how we identify it is positive or negative? How you want to identify R is positive and negative? Okay, do take note here. If the object position is opposite side with the R, of course, the radius of this circle, right? So if the object is opposite side with the R is positive. if the object same side with the R is negative. So in this case, if you look at the radius of the green circle is in this side and the object is in the opposite side. So R-nya adalah positif. Same for the second surface. Second surface, R is in the opposite side with the object. So both R is positive. Okay, so you tak perlu hafal lah convex surfaces. Because kalau you hafal convex surface ataupun concave surface positive negative, you still need to identify which one is convex, which one is the concave surface. Okay, so that's the tips lah. If you want to use it, you can use it. Okay, but it is depends on you. If your lecturer, if what I explained to you different what your lecturer explained before this, please refer to your main lecturer. Okay, that's very important. Please refer to your lecturer. Okay, so I just share the tips. Okay, if different, it is okay. If you understand your previous explanation, it is okay. You can follow which one that can help you to answer correctly in the final exam. Okay, so to determine the focal length, we can use the lens maker equation. So lens maker equation is equation number 70. Okay, the tips is how you want to identify which equation that you want to use, because you also can use equation 67, right? But if you look at here, there are R1 and R2, which is referring to the equation 70, lens maker equation. So you need to substitute correctly. Okay, let's say if you want to ask me, madam, what happen if I put the object in front of the yellow surface? Can or cannot? Can. You can put here, you can put your object at this side. So what happened? So your R1 will become 15 centimeter, but object located same side with the radius. So your R1 is negative 15 and your R2 will be negative 50. So when you substitute, you will get the same answer. Believe me, kalau tak percaya, you try. Try substitute. R1 is negative 15, R2 is negative 50 because of you want to put the object in front here, right? So you still can follow these rules. You will get both R is negative, so you will get the same answer. So referring to the focal length, F is a negative value. So for the types of lens, we know that if F negative, it is a concave lens. Okay, and in this case, your maybe your previous knowledge, this is called concave meniscus. Okay, concave meniscus lens. All right. So if you have any question, it is okay. You can refer to me, or you also can refer to your lecturer, previous lecturer. Okay, no worries. You can ask. All right, for question number 6C. Okay, for question number 6C, it is show an object and a glass rod immersed in a liquid. Immersed in a liquid. The rod has the refractive index of 1.7 and radius curvature 8. Okay, take a look at the list of information given. Okay, if the object distance is 15 centimeter and the virtual image distance is 13 centimeter, determine the refractive index of the liquid. Okay, referring to the question, when you list the information given, okay, and 2 no problem because of the refractive index for the glass is 1.7. Okay. And then okay, why the radius of curvature is 8 centimeter? Why the R is negative 8? I write down there R is negative 8. Why? If you look at the object now, so object. And then take a look at the spherical surface. Spherical surface. The radius is same side with the object, right? Because of the object is same side with the R, so R is negative. That's the hidden information. Kalau you write down the R is positive, you kill yourself. Okay, make sure that you understand well. And then U is 15, of course, because of U is in front of the surface. And then V, why I write down V is negative? Because of if you refer, is stated the virtual image. So kita tahu kalau virtual image, V mesti negative. So negative 13 cm. So in this case, if you look at here, I'm not change to the SI unit because if you use the same unit, it is okay. If you can form the same unit, it is okay. So please be careful. And we want to calculate the refractive index of the liquid. Okay, so for the refractive index of the liquid, because we immerse the object inside the liquid, so it is considered N1 lah. N1. We want to calculate the N1. Okay, we will refer to spherical surface equation because there are two different medium, and we have the one radius of curvature. So that's the best equation is the equation 69, which is spherical surface equation. So referring to this equation, you need to identify the position of the knee. Actually, 15 is referred to the object distance, right? Object distance is 15 centimeter. So it is referred to the not the position of not the position of object. N1 is referred to the where is the incidence ray located. So in this case, luckily object kita dalam liquid, so incidence ray of course in the liquid. So it is N1 that we want to calculate the refractive index. Okay, and our object is in the glass, so N2 is the glass, and then just substitute the value, and do take note that the R is supposed to substitute -8. And because of that, if you calculate, you will get that the refractive index of the liquid is equal to 1.4. Okay, no unit for the refractive index. Okay, is it clear? So the part that I want to highlight is to identify R is negative. Okay, make sure that you know the concept. If the object same position with the R is negative. And if stated the virtual image, so of course you need to put the sign for the image, for the V, which is supposed to be negative. Okay. So that's it for question number 6. Now we go to the question number 7. Question number 7 is the physical optic. Physical optic. So we have another 20 minutes. So I hope that you can bersabar. Okay. So for question number 7A, this is about the physical optic, which is a double slit experiment. So the incidence ray, okay, take a look. The wavelength of the incidence, the wavelength of the ray, light is 660 nanometer. Okay, the slit separation is 0.25 millimeter. Okay, take a look the things that I list here, and the screen is placed 90 centimeter. So D is 0.9 meter away from the slit. If you see the the list of information tak sekata ada setengah satu unit, ada setengah satu unit. Okay, take a look at the solution. First, we want to calculate the distance from the second to the third destructive interference fringe. So this is double slit experiment. For the distance from the second and third slit is referred to the separation distance between the or the distance between the two consecutive bright or two consecutive dark fringe. Okay, because of that, the equation that we refer is the equation, the number of equation is equation 73, the separation distance equation. Delta y is equal to lambda d over d. Okay, so sebenarnya gangguan je, dia mention second to the third destructive interference fringe. So actually it is a consecutive dark. Distance between the two consecutive dark. Okay, so because of that, referring to the information given, you just need to substitute correctly. And in this case, memang saya senaraikan, I put nano and milli. So in this case, I just write down nano is 10 power negative 9, milli is 10 power negative 3 when I substitute. So my final answer supposed to be in the meter unit, which is 2.376 times 10 power negative 3 meter. Okay, that's the separation distance between the second and the third destructive fringe or dark fringe. Okay, and for question number 2, the double slit is now replaced with the diffraction grating. So I hope that when we mention the diffraction grating, you remember the last experiment for this semester about the diffraction grating, you need to imagine that experiment. So if the maximum number of bright fringe is 15, calculate the slit separation of the grating. Okay, slit separation meaning that we want to calculate the D. The D, So, and also for the diffraction grating, it is the last topic in this topic. Last subtopic in topic 7, in topic 8, geometrical physical optic. So persamaannya mesti yang last iaitu persamaan 78 and also equation 79. Okay, so first we will identify the hidden concept. Okay, hidden info. What is the hidden info? The maximum number of bright fringe is 15. What does it mean by apa hidden info yang kita dapat for the maximum number of bright fringe, which is 15? First, maximum fringe. Maximum fringe hidden information adalah tetanya is in 90. Maknanya the widest separation distance, the widest separation angle. Okay, so theta is 90 degree for the maximum fringe that can be observed on the screen. And also for the 15 bright fringe, we can identify the order. So the order is not 15, So remember, if maximum bright fringe, which is 15, can be observed, meaning that for the diffraction grating at the center is bright, right? So center satu bright, atasnya 7, bawahnya 7, betul? So 7 campur 7, 14, campur tengah 1 jadi 15. That's why we can form 15 bright fringe, meaning that the order is actually 7. Okay, the order is actually 7. Okay, because when after you identify this one, then you can refer to the equation, which is equation 78. Or another way, you boleh identify the equation first. You know it is a diffraction grating. So equation kita kena guna equation 78. D sin theta is equal to n lambda. So you tengok apa maklumat yang you ada. So far kita ada lambda, then we want to calculate the D. Okay, slit separation bila kita replace with the diffraction grating. So, kita tak ada theta dengan N, betul tak? So, you need from the question, you need to be careful, read carefully to identify the theta and also the N. Then, later on, you substitute and you will get the answer for D, which is slit separation is 4.62 times 10 power negative 6 meter. Clear? I hope that you understand, yeah? Okay, now we go to the question number 7B. This is about the thin film interference from the reflected light on the thin film. Okay, so a soap film with a refractive index. Okay, I love to list the information when I read the question. N is 1.3. Minimum thickness. Okay, given there, appear reddish under white light. So what you need to calculate is calculate the wavelength of the light. So lambda that you want to calculate missing from the reflection. So missing meaning that hidden information in the light, it is a destructive interference pattern. So maybe you can sketch the soap bubble interference for the soap bubble. So in this case, actually you need to identify the film. The film is the soap bubble. So I just write down here upper surface and lower surface. Why I write down the upper surface and lower surface? For you to understand that the reflected ray is at the upper surface of the soap bubble and the lower surface of the soap bubble. From that reflected surface, we can identify the phase change. Because in this case, for the upper surface, the light reflected on the denser medium, so pyradion phase change. But for the lower surface, the ray is reflected at the less dense medium, so zero phase change. So apa fungsi when we know the phase change? Because we want to calculate the wavelength of the light. It is a lot of equation. Of course, I'm sure that you can identify about the thin film. The equation is equation 74 and 75. But which one? Which one? 74 or 75? Dia either one. So your marks 50-50. Sayang kan dah 50% garanti betul. Tapi kalau you salah pilih, kosong. Okay? Jadinya, this phase change we use to identify the phase difference. So in this case, because of when we calculate the phase difference, we get pi. Pi meaning that this is anti-phase. Okay, two coherent source anti-phase. And also, because of its stated missing, we know it is a destructive. So for the path different equation, for the destructive interference and anti-phase source, so the equation is 2nt is equal to m lambda. Okay, maknanya persalaan kita akan guna adalah 74. Dia terbalik ya, kalau dia in phase, destructive-nya adalah m plus half. Okay, so make sure that you alert about the anti-phase dengan in-phase source, two coherent source. Okay, now we have identified the equation for the path different. Okay, because of in this equation kita ada lambda that we can calculate. But now we have the 2, we have the n, and we have the n and t. But how about the m? So what is the value for m that we can substitute? It is because it is minimum thickness. Okay, other tips. There are two things. Okay, that you need to refer. If the equation is 2nt is equal to m lambda, for the minimum thickness, m is equal to 1. Let's say if you substitute m is equal to 0, maknanya you cannot calculate the minimum thickness, for example. Am I right? So for this equation, if the path different is m lambda, so m is equal to 1. But if the path different equation m plus half lambda, so m for the minimum thickness, m is equal to 0. Okay, please remember that. Make sure that you know how to use it. And because of that, we just substitute the value, and then we can calculate the wavelength will be given as 460 nanometer. Okay, for the wavelength of the missing, the wavelength of light that missing from the reflection. Okay, in the soap bubble film. Clear, right? Okay, and then question number 8. So question number 8, this is actually question number 8, 9 and 10 supposed to be your bonus. Make sure that you can answer it correctly. Okay, but take a look at this session punya soalan. So for question number 8, figure 8 shows a graph of photoelectron, maximum kinetic energy against frequency. Okay, from a photoelectric experiment. Kalau kita tengok, kita hanya ada satu je nilai yang diberi. So what you want to list? Satu nilai lah. So nilai ni nilai apa? So kalau you sekali tengok, it's look like that it is a Kmax, right? But please understand, this is information from the graph. Gradient, kita tahu we will get the gradient, how to calculate the gradient and all the things. So untuk graph ni, actually from this graph, if you match, because of this is photoelectric effect, kita ada Einstein photoelectric effect equation, which is represented by equation 80. Equation 81 or equation 83. That's the Einstein photoelectric effect equation. So referring to this graph, kita ada persamaan Kmax sama dengan because of y-axis kita meshkan dengan straight line graph, because of this is straight line graph, right? So y is equal to mx minus c. So in this case, Kmax is at the y-axis. X kita adalah frequency. So hf minus width intersection at the y-axis is work function. So referring to the equation, which is we mesh with the straight line graph, then we get the information, which is actually it is considered as hidden information. 2.28. This is actually the what we call it work function. Okay, it is the value for the work function. So because of that, first you need to calculate the maximum speed of the photoelectron. So maximum speed of the photoelectron maknanya Vmax. What you need to do? So you can refer to the equation which is related to the Kmax lah. Because of, if for the Kmax, maximum kinetic energy of the photoelectron, V is supposed to be Vmax. So referring to the equation, if we rearrange because we want to calculate the Vmax, it is equal to set2 Kmax divided by Me. And if you look at the given information, kita hanya ada nilai mass of electron saja, which is in the list of selected constant, right? So you just need to substitute the value, and your answer for the Vmax supposed to be in terms of set Kmax, because of we have no value for Kmax referring to this question. So you still can answer the question by in terms of the value that not given. Okay, so this is the way how to answer this question. Okay, please ignore because of if I'm not mistaken, there are few college that what they do, they change the question and they give the value for F so they can calculate actually. So I just refer originally the question from this session. Okay, to calculate the stopping potential, same thing. For the Kmax, to calculate the Vmax, we use the Kmax equation, and for the stopping potential also we can get from the Kmax equation. So referring to the Kmax is equal to EVS, okay, we want to calculate the stopping potential. So Kmax is equal to E is referred to the elementary charge. We just need to substitute the value and you can give your answer in terms of Kmax. But don't forget the unit. For example, just now Vmax is ms minus 1. For the stopping potential, the unit is volt. But in terms of Kmax, because of we have no value for Kmax in this question. Okay? So this is just try to answer the question actually. Kalau you rasa maklumat tak cukup, you can leave it your answer in terms of the information that not enough tu. Okay. And then for C, we want to calculate the threshold frequency. Okay, yang ni kita lega sikit because of we know the work function. So referring to the equation of work function, which is equal to HF naught, referring to the equation 82, you can calculate the threshold frequency, which is equal to 5.5 times 10 power 14 Hertz. Okay, so that's the answer. Unless, actually this question unless kalau kita nak kira threshold frequency first, okay, we can get the maximum speed and all these things. Okay, because of the threshold frequency is the last part, so it is quite difficult for us to calculate the maximum speed and stopping potential. Okay, so this is the solution for question number 8, and for question number 9, which is from, if I'm not mistaken, question 9 is from the quantization of light or wave particle duality, which is about this is division germ experiment. So a beam of electron is accelerated through a potential difference of 4500 volt in a division German experiment. So first we need to calculate the de Broglie wavelength of the electron. So it is a lot of hidden information. The given information is only V actually. So the hidden information, because of we talk about the electron, we have elementary charge and also the mass of the electron. And because of that, to calculate the de Broglie wavelength of the electron, the de Broglie wavelength given two equation in the list of the formula, equation 84, equation 85. So in this case, because of given the V, we can use equation 85. Okay, and we have the mass of the electron and also the elementary charge. So you just need to substitute also the H Planck constant, and you will get that the de Broglie wavelength for the electron is 1.83 times 10 power 11 meter. This is direct. If you remember, starting from question number 1, I can say that more than 70% direct, meaning that you choose the correct equation, you substitute correctly, and you get the final answer. That's the way of the PSPM question. Only 25%, 25 or 20% sahaja yang you need to do few calculation, then you get the final answer. Okay. Alright, now, will the diffraction pattern become larger, remain unchanged, or narrower when the proton is used instead of electron? So in this case, you need to justify your answer. So what is the difference between the proton and neutron? What is the difference between the proton and the electron in terms of mass, right? The mass of proton and the mass of electron. So if you refer to the mass of proton, which is 1.672 times 10 power negative 27. Mass of electron is 9.11 times 10 power negative 31. So mass of proton is greater compared to the mass of electron. So referring to this equation also, we get the relationship between the wavelength and the mass. Wavelength is that inversely proportional to the mass. Okay, in this case, yeah. And we know that the mass, when we replace with the proton, where the mass of the proton is increased. So when the mass is increased, the wavelength will decrease. So what happens when the wavelength is decreased or shorter wavelength? So the pattern will become narrower. Okay, the pattern will become narrower. So this is how you justify your answer. Justification, you can use the equation, you can use the value, or you can use the explanation. But normally we refer to the relationship. And for you to use the relationship, you need to refer to one the equation that relate between these two items, which is mass and the wavelength. Okay, and for question number 10, our last question, and there are two question for the last question. So 10A, we need to calculate the binding energy per nucleon of the sodium nucleus in mega electron volt per nucleon, and given the atomic mass. Okay, ini satu hal. Okay, so we want to calculate the binding energy per nucleon. Okay, binding energy per nucleon. So referring to the sodium nucleus, we can identify the nucleon number, the proton number, and the nucleon number. Okay, we identify from the numbers here. And given is the mass of the atom. Okay, first, before we calculate the binding energy itself, we need to calculate the mass defect. Remember, the equation for mass defect is ZMP plus NMP minus with M nucleus. So do the M nucleus given in the question? No, right. There's no mass of the nucleus. What you need to do? So you need to calculate first. For the mass of nucleus, it is equal to mass of the atom minus with the total mass of the electron, because of nucleus is only consists of proton and neutron. Kalau atom consists of proton, neutron, and electron. So to calculate the mass of the nucleus, you need to minus mass of the atom with the total mass of the electron. So we know that the numbers of electron is equal to the numbers of proton. So Z times with the mass of electron. So you will get the mass nucleus, okay, which is consists of proton and neutron only. So when you get the mass of nucleus, you can calculate the mass defect. So in this case, I just substitute in the equation of binding energy because I want to calculate the binding energy first. So when I calculate, make sure that you substitute correctly Z N, okay, inside the equation. Okay, and also the mass of nucleus that you have calculated here. And after you calculated the mass defect, okay, so C square, leave it C square here, and then referring to the answer for the mass defect ni, jawapannya dalam U, am I right? So referring to the list of selected constant, okay, this is quite special because of list of selected constant ni agak panjang, iaitu muka surat belakang ya, atomic mass unit. Dia bagi atomic mass unit 1U is equal to 931.5 mega electron volt per C square. So I just replace U as 931.5 mega electron volt per C square. Do take note that you need to substitute the unit too. Okay, because of why? This here is C square, right? No need to substitute the C square, but we can cancel both. We can cancel the C square, and because of that, you can calculate the binding energy, which is equal to 186.6 mega electron volt. And don't forget, the question asks you to calculate the binding energy per nucleon. So when you substitute, you will get the answer, which is 8.11 times 8.11 mega electron volt per nucleon. So that's the answer for the binding energy per nucleon. And okay, I hope that if I am too fast, you can refer back to this video later
Madam,
on. Eh?
Madam,
Yes.
Madam Nun, we already tinggal lagi 2 minit je.
Okay, right. This is our last question. Thank you so much, Madam Shaida. So for question number 10B, calculate the activity of 5 microgram natrium with the half-life of 14.9. So referring to this, we want to calculate the activity, where the equation for activity is actually the decay rate, so also equal to lambda n. So you also can refer to the list of selected formula given to you. And M is the mass of the natrium, 5 microgram, and a molar mass referring to here is 24 gram, and the half-life. So the hidden information that you get is, if you have the half-life, you can calculate the decay constant, which is lambda. In this case, lambda is the decay constant, and I change to the SI unit directly. And referring to the equation of A, activity is equal to lambda n, we have the lambda here, we have the decay constant. So now we need to calculate the n, the remaining nuclei. So to calculate the remaining nuclei, you remember this equation? This is equation introduced you in semester 1 or in chemistry. I'm sure that you are familiar with this equation. So to calculate the remaining nuclear, it is equal to mass of the nucleus divided by the molar mass times with the Avogadro number, which is given in the list of selected constant, and you will get the n. After you get the n, you just need to substitute in the equation of activity, which is lambda n, and you will get the answer for activity is 1.62 times 10 power of 12 decay per second. Okay, so this is two steps of solving this question. So it is considered C4. Alright, but this is your previous knowledge actually. It is very easy, but you need to think to calculate, and this is can help you is by identifying the equation that you want to use. So I think that's it for my presentation. So I wish all of you good luck and all the best. And for those who are attending this Sesi Ulangkaji Berfokus, I really pray for your success in the PSPM. Okay, so that's it. I give back to our moderator, Madam Syaida. Thank you so much.
Okay, terima kasih Madam Nun. Sesi ulang kaji kita telah sampai ke penghujungnya. Syabas kepada semua pelajar atas kesabaran dan perhatian yang telah diberikan sepanjang sesi YouTube live tadi. Mudah-mudahan ada sesuatu yang telah anda perolehi pada sesi ulang kaji hari ini. Sebagaimana yang janjikan di awal tadi, Madam telah share link kehadiran dan borang penilaian di ruangan chat. Mohon pelajar untuk isi dan link ini akan dibuka selama 30 minit sahaja. Madam mohon juga kepada yang ada sekarang ni, tadi ada 60 orang untuk tekan button like and subscribe lah untuk unit Fizik. Ini akan menaikkan lagi lah semangat pesyarat untuk membuat sesi seperti ini di masa akan datang. Sebelum bersurai, Madam mewakili Jawatan Kuasa Program Kecemerlangan Kolej merakamkan ucapan terima kasih kepada semua pihak yang terlibat, ataupun Madam Nun lah, yang untuk memastikan penganjuran sesi ulang kaji berjalan dengan jayanya pada hari ini. Terima kasih juga kepada Sir Edward dan juga Madam Emma. Okey, mohon maaf dari Madam Andana ada kata kasar bahasa terlanjur bicara sepanjang mengendalikan sesi ulang kaji sebentar tadi. Sesungguhnya yang terbaik itu datang daripada Allah Subhanahu Wa Taala dan kekurangan itu adalah kelemahan daripada Madam sendirilah. Okey, so good luck for your PSPM. Sekian, wabillahi taufiq wa hidayah. Terima kasih semua. Bye.